Hi learners, welcome to the Introduction to Data Mining. Myself Priyanka Gupta, working as Assistant Professor in Computer Science and Engineering Department of Data Science at IARE Hyderabad. So today's topic is Introduction of Data Mining, Data and its Types. Today I'll be covering the contents are what is data mining, data and its sources, data objects and attribute types, basic statistical description of data, data visualization, measuring data similarity and dissimilarity, and summary. So, what is data mining? What is data mining subject? Data mining is the practice of analyzing large databases in order to generate new information. What is data mining? It is the practice of analyzing large databases in order to generate new information. And the data mining, it is going to be used in the various industries, various companies for the business intelligence process. Data mining is the process of searching, extracting, and analyzing, discovering various types of text graphic, their patterns, languages, and literary figures, stylistics in large amount of textual, mixed visual, and textual data sets. So, data mining is a process of searching, extracting, and analyzing data sets. These type of data sets that also involves methods at the intersection of some of the fields. That is nothing as machine learning, formal linguistic analysis as textual statistics, and database systems. So data mining is the process of searching, extracting, analyzing various types of data sets that involves the intersection of machine learning, statistics, and database systems. So what is data mining? Data plus mining. What is data in that? Larger data sets. We are working on larger data sets for data mining. What is mining in that? Mining is the knowledge discovery, that type of databases. So this is the whole description of data mining. Data mining uses mathematical analysis to derive patterns and trends that exist in the data. We are fetching the patterns and various trends from the data using mathematical analysis. So that was the data mining in the data mining subject. What is data in that? Data is, we don't generally associate data with statistics. We don't generally associate data with mathematics. That is purely a statistics. However, data is the base of all operations in statistics. So we are performing only some of the operations in statistics. Data is a set of value of objects represent to qualitative and quantitative variables. So that is a set of value of subjects with respect to qualitative and quantitative variables. Qualitative and quantitative variables. So data is raw, unorganized. The data we are going to use is very, very raw. That is also unorganized fact. We are calling as fact that need to be processed. In data mining, we need to process that raw data. Data can be something simple and seemingly random and useless until it is organized. So, before we are going to use data mining, we need to organize that data. We need to do some of the processes to organize that raw data into organized and ordered data. When data is processed and organized and structured and presented in a given context so that to make it useful, after that it will be useful for presentation, that we call as information. So the fact that are going to be present, we will call as information. Information necessary for research activity are achieved in different form. The main form of the information that are available with us, that is primary data, secondary data, cross-sectional data, categorical data, time series data, spatial data, and ordered data. These are the some form of the information that is available. What are the data sources from where we can choose that data, that raw data? So primary data. Primary data is nothing but it is the original and unique data which is directly collected by the researcher from a source according to his requirement. So that data is very very pure data which is directly collected by the person. So that is very very authentic data. For his research purpose, the user is going to require that data, and he need to collect that type of data. Secondary data refers to the data which has already been collected from a certain purpose and then documented somewhere else. So that is the data which is already exists. The data already exists and we need to use that data for our use. Cross-sectional data is nothing but it is a type of data that is collected by observing many subjects, that is from the such as individuals, firms, many countries and regions at the same point of time, without regard to differences in time. At the same time are differences in the time. So that is a cross-sectional data which is collected by observing many subjects by the various individuals, firms, countries and regions. Categorical data. What is categorical data? Categorical data is nothing but it represents the types of data which may be divided into groups. That may be divided into groups. That type of data we call as categorical data. For example, categorical data is race, sex, age group, and educational level. Suppose we are having gender. So gender is of two types, male, female, and another also is transgender. So these are three types of variations in gender. So like that, it is divided into some of the groups. What is time series data? Time series data, it is occurs whenever the same measurement are recorded on a regular basis. The quantities that represent or trace the value taken by the variable over a period of time, like a month and a year and quarter, that is been recorded and taken. So that will be the time series data. That is nothing but related to time. Spatial data. That is a very very interesting data. Spatial data is nothing but it is related to geographic data. That is geospatial data or geographic information. That is the data information that identifies the geographic location of features and their boundary on Earth, such as natural or constructed features that is constructed by man, ocean, and others. So the spatial data consists of points, lines, polygons, and other geographic and geometric primitives, which can be mapped by the location. So the spatial data, that is the graphical data that can be mapped by the location and stored with an object as metadata. And that is also used by the communication system to locate the end user devices. To locate the end user devices. Like we can say there are some satellites. There are satellites from where we are getting some type of data, some type of spatial data that is recorded on that end user devices, and then that is communicating to us, and that is being recorded in the machine, and we can check the different geographic data from that device. So that is spatial data. So what are the types of data sets? There are many types of data sets. There are records, there are graphs and networks, there are ordered data, there are spatial and image and multimedia data, as we have checked. So what is record actually? The record is nothing but it is the relational records, relational database record that is stored in the form of record. The data matrix, we can say numerical matrix, that is also called as crosstab. That is also document data, the text document that we also call as frequency vector. That is also maybe the transactional data. What are the graphs and network data? The World Wide Web data, the social media and information network data, the molecular structure data that is related to chemistry. So we are also have ordered type of data. What is this? The video data. In this type of data, the video data exists, temporal data exists, sequence data exists, and genetic sequence data also exists. Video data is nothing but the sequence of some images. So that is a sequence of images we can see as a video that is running. So that is nothing but the sequence of images. What is temporal data? That is nothing but the time series data that we have already been through with the earlier slides. What is sequence data? That is nothing but transaction sequences. That is the transaction sequences data. Genetic sequence data, that is nothing but the related to medical field data, that also contains genetic type of data. Spatial, image and multimedia data. So in the spatial data, what we are having? Maps, the graphical maps, image data and video data. So that comes under the spatial, image and multimedia. So these were some types of data sets we have studied. So important characteristics of structured data. What is structured data? That is organized in the order, some of the order, that is called as sequence structured data. So these are the some characteristics we need to check on that. We should know that there is dimensionality, sparsity, resolution and distribution. Dimensionality, the curse of dimensionality reduction. So we need to remove that dimensionality reduction. We will check in the next some of the classes. Avoid the curse of dimensionality. So we need to avoid that from the various methods. We need to apply some methods on that. Then it will be eliminate. Help to eliminate irrelevant features and reduce the noise. There will be some noisy data also. We need to remove that also. We need to reduce time and space required in the data mining. That also allow to easier visualization, easier presentation. Sparsity, only presence counts. That only presence in the counts. Resolution, patterns depend on the scale. So some of the pattern that depends on the scale that only exists for the resolution. Distribution, centrality and dispersion exists in the distribution. So these were the some important characteristics of the structured type of data. Data objects. What are data objects? Data sets are made of the data objects. Some of the data sets that are made of the data objects, that is called as a data object. A data object represents an entity. So we can also call the data object as an entity. Some example are there. Let's take an example. There is a sales database in which we are having customers, store items and sales. There is medical database, we are having patients, treatments. There is university database, we are having students, professors and courses as data items. So it is also called samples. For example, instances, data points, objects and tuples. So the data object we can also say as entity, instances, data points and objects. Also samples. So the data objects are described by the attributes. Data objects are described by attributes. Database rows is described as data object and database column is described as attributes. What is attribute? Attribute or dimension we can also call as features and variables. A data field that is representing a characteristics or feature of a data object. That is the characteristics of a data object. There are some types of that: nominal, binary, numeric, that is also quantitative. In quantitative, these are of two types, that is interval scale and ratio scale. In interval scale, the data having some of the interval, regular interval, and for the ratio scale, there will be the ratio for the data that exists. Attribute types. So in detail we will check what are the different attributes. So nominal. Nominal is the category, state or name of things. So what is the nominal attribute? It is nothing but the name of things. We can have some example, that hair color, marital state, occupation, ID number, zip code. So for the hair color we are having black. There are some types: black, gray, red, white. So these are the name of things. Marital state is also having unmarried and married. That also the occupation is also having some of the name of things. ID numbers is also having. So what is binary attribute? That is a nominal attribute with only two states, that is 0 or 1. 0 and 1. That is only having 0, either 1. So that is also are two types: symmetric binary and asymmetric binary. What is symmetric binary? Both outcomes equally important. For the example, if we are having gender, so if we are having male or female, so for the event occurrence, the both are very, very important. What is asymmetric binary? That outcome is not equally important. So for example, if we are having some medical test data, so if there is positive and negative, so that is not more important. Either it will be positive, either the outcome will be negative. Only it will be depend on the one event. So convention: assign 1 to most important income. That is HIV positive. That I have said, that is only will be the one important, either positive or negative. Ordinal. What is ordinal attribute? Ordinal attribute is nothing but the value that having a meaningful order or ranking. That is having a order or ranking. The data which is having the order or ranking, that is the ordinal data. as name says, ordinal. But in that the magnitude between the successive value is we cannot know. So for example, if we are having size is equal to small, medium and large, we are having grades and army ranking. So these are the some meaningful order, but the successive value we cannot know. Either it can be small, medium or large, like that. Numeric attribute. So what is numeric attribute? That is having quantity. That is having quantity, integer or real value. The interval type of data, it is also having the numeric type of attribute, the interval type of data. So what is interval? Interval is nothing but the equal size unit that is measured on a scale of equal sized units. The value have some order. For example, if we are having temperature in and calendar dates, so there should have some type of order. Temperature also will have some type of order. Calendar dates will also have some type of order. So here no true 0 point will occur. What is ratio type of numeric attribute type? That is inherent 0 point. That will be inherent 0 point. So we can speak of value as being an order to magnitude larger than the unit of measurement. That is 10 is a twice of 5 degree Kelvin. 10 is the double of 5 Kelvin. So that is the order of magnitude larger than the unit of measurement. For example, if you like same example, temperature in Kelvin, length, count, monetary quantities. So these are the some type of ratio type of numeric attribute type. Discrete or continuous attribute. What are discrete attributes? Discrete attributes has only a finite or countably infinite set of value. For example, if we are having zip code, we are having profession, are the set of words in a collection of document. So here will be the infinite set of value. If we are having zip code, so for example, if we are taking 5043, so this is for example, we are having zip code. So this will be the finite and countably infinite set of value. So we cannot say this as that is not a finite set of value. That is a finite set of value. So sometimes that represents as integer variables. The binary attributes are a special case of discrete variables. Discrete attributes. So here continuous attribute. Continuous attribute has real numbers as attribute value. So these are having some real numbers. For example, if you are having temperature, height and weight. So practically the real value can only be measured and represented using a finite number of digit. So there will be digit to measure that and represent that type of digits for the example. So continuous attributes are typically presented as floating point variables. Sometimes we will also represent the floating type value, floating point variables, floating points. That is having decimal points, like we can say like that. So this type of attribute is also comes under the continuous type of attribute. A statistical description of data. What is motivation behind that? To better understand the data, we are having some measures, that is central tendency, variation and spread for to measure that type of data. The data dispersion characteristics like median, max, minimum, quantiles, outliers, and variance. So these are the some measures to measure the data for to understand about the data, how it is, how the data order is existing. Numerical dimensions correspond to the sorted intervals. For example, data dispersion. Data dispersion analyzed with the multiple granularities and precision. So that is analyzed with multiple granularities of precision. So that is called as a data dispersion. We can also that represent that data in a box plot or quantile analysis for the sorted intervals. If in that type of data we are having sorted intervals, then we will plot the box plot for the visualization. Or we can also have the quantile analysis for the for to see the data dispersion, to variation of the data, to see the variation of the that data. Dispersion analysis on computed measures. So folding measures into numerical dimensions. We need to fold the measures into numerical dimensions. We need to box plot a quantile analysis on the transform cubes. So these are the two methods to do that while we are having dispersion analysis for the computed measures. So these were the some statistical description for the data we need to use to understand about the data. So we need to measure the central tendency, that is the statistical description. So what is central tendency? Central tendency is nothing but we are having some set of calculations like mean, median, average. So we need to calculate those on some as a statistical analysis. So what is mean? Mean is nothing but the average of the all ordered data. So note any when we are having algebraic samples, so we will use that mean. We need to apply that mean. So there are some examples that are also weighted arithmetic mean. So we need to calculate that as a x bar is equal to 1 upon n sigma n to I is equal to 1 xi. So what is xi? Xi is the nothing but the number of that is a number of sets, number of data sets. So we need to calculate the x bar from that, and by that we need to calculate mu is equal to sigma x upon n. N is the total number of sets. So from there we can get the mean. We will get the mean of the total values. So there is also trimmed mean. In that we need to chop the extreme value. If we are having some extreme value, we need to chop that. Then after we need to calculate the mean. So this is the formula for to calculate the mean from the for the extreme value. So that is x bar is equal to sigma n to I is equal to n 1 wi xi upon sigma n to I is equal to 1 wi. So that is the calculation to check the mean of the extreme value. What is median? Median value if odd number of value are average of the middle two value. Middle two value average is called as a median. That is estimated by interpolation for the group type of data. So what is the formula for that? Median is equal to L1 plus n by 2 minus sigma frequency upon frequency median into whole of the width. So this is some data set. On that we need to calculate the median. So we will check. So it is only the value that occurs most frequency of the data. the uni-model, bi-model and tri-model. So we can also calculate the uni-model, bi-model and tri-model of the data set. So the imperial formula will be that for the mean minus mode is equal to 3 into mean minus median. So that is a mode. That was the median. Mode is a nothing but value that occurs most frequently in the data set. So if we are having 2, 2, 3, 4, 5, 2, so 2, 2, 2, that is occurring most of the time. So that will be the mode for this data set. Mode is equal to 2. So that is frequently occurring. So in this, for the example of median, we are having age and frequency. In age, we are having the value 1 to 5, 6 to 15, 16 to 20, 21 to 50, 51 to 80 and 81 to 100. And frequency we are having 200, 450, 300, 1500 and 1500, 700 and 44. So we need to calculate the median from this formula. That is nothing but L1 plus n upon 2 minus sigma frequency upon frequency whole of the into of width. So that is the formula to calculate the median of the data set. So that was the central tendency for some data set. Symmetric and skewed data. So mean, median and mode of symmetric, positively and negatively skewed data. So that is the skewed data. That is shown as a form of graph. So here we can check, this is the some plot of the some data set. So this is like that we are having the graph. So here the mean it is comes after the right-handed side. The mean is coming here, the median is coming here, and the mode is coming here. So that the mean is coming in right hand side, so we will call as positively skewed data. So that is the positively skewed dispersion of the data. So in this we are having symmetrical distribution of the data because it is having this type of flow. So in middle we are having mean, median, mode, the same as the mean, median, mode will be the same in the symmetrical distribution. So that is negatively skewed data. In this type of data, the mean exists in the left hand side of the data. So here the mean we can take the median and mode. So that is the negatively skewed data. Measuring the dispersion of data. So what are the measures to measure the dispersion of data? So for quartiles, outliers and box plots, we can check the quartiles that are having Q1, Q2, Q3, Q4, Q5 like that quartiles. So in first quartile, that is the first quartile for the box plotting the data set. So that is the first quartile. First quartile is nothing but the 25th percentile of the data. So there is also Q3. Q3 is nothing but the 75th percentile of the data. Q2 is nothing but at the 50th percentile of the data. So like that we need to calculate that type of data. So from these 5 number summary, this is the 5 number summary Q1 to Q5. So what is interquartile range? IQR, interquartile range. Interquartile range is nothing but we need to calculate from the Q3 minus Q1. From the third quartile we need to minus the first quartile. So we will get the IQR of the data. Interquartile range of the data. So I have said that first 5 number summary. So we can call as a minimum, Q1, median, Q3 and maximum. So minimum we can calculate, Q1 we can calculate from the data, median we are having the formula, Q3 is the third quartile and maximum from the data set. So this is the 5 number summary. Box plot. So box plot ends of the box are the quartiles. So median is marked, in that we need to add whiskers. So for example, we are having the box plot is like that. For some type of data set, we are having box plot like that. So here, anywhere from the data, we can have the, it depends on the data, the mean exists where. So there, the mean exists, median exists. For example, if the mean, median and mode exist, here the Q1 and here somewhere Q1 exists, here somewhere Q3 exists. So like that, the data will be dispersed. We can represent that data in the box, in the form of box plot. So these are the whiskers. These are the whiskers we need to add, and the plot outliers individually. So here some of the outlier can exist. What is outlier? Outlier is nothing but the data that is the out of the boundary of the data set. So that is called as an outlier. So we need to plot the outliers individually. That was the representation of the box plot. So outlier usually a value higher or lower than 1.5 into IQR. So we can also calculate the outlier if it is having 1.5 into IQR. So that can be lower or higher. So we can calculate the IQR from the Q3 minus Q1, and then we need to multiply with it 1.5. So then we can calculate the outlier for the data set. Variance and standard deviation from the sample and from the population. So that will be calculated for sample and for the population. So what is population? Population is nothing but the set of all data sets that exist. And sample that is nothing but the some of the sample we are taking from that population. Some of the data set we are taking from the population, that is called as a sample. So that if that will be true, so the population also will be true for that. For some of the population we can call that true. So we will calculate the variance and standard deviation for that. What will be the formula for variance? Variance will be algebraic and scalable computation. So we will calculate the variance. S square is equal to 1 upon n minus 1 summation n to I is equal to 1 in square xi minus x bar whole square. So that is the calculation for to compute the variance. So in detail we can conclude that 1 upon n minus 1 xi square minus 1 upon n sigma n I is equal to 1 xi square whole square. So that we have opened that formula into one single line. So how we can this is the variance to calculate the from the sum of the data set, sum of the sample. So we need to calculate standard deviation also. So the formula is 1 upon n summation n to I is equal to I xi minus mu whole square. So what is mu? That was the mean of the data. We need to first calculate the mean of the data. Then after we need to calculate the variance for the data set, for the population and sample. So standard deviation sigma is the square root of variance. That is the square root of variance, we can say. So what we call if we are calculating the variance, then after the standard deviation will be the square root of that calculation. So in the detail, we need to check the box plot analysis. So what is box plot analysis? That we have seen in earlier slides, the 5-number summary of the distribution. There are some data distribution that have 5-number summary: minimum, Q1, median, Q3, and maximum. So what is box plot? Box plot is a data is represented with a block, with a box. So the ends of the box are at the first and third quartiles if the height of the box is IQR. So the median is marked by a line within the box. Here we can check the median is marked with the line. Here we can check the minimum. Here we can check the maximum. So this is the representation of the box plot. This is the IQR. This is the Q1. This is the Q3. So this is the representation of the box plot. Whiskers. Whiskers are the two lines outside the box extended to minimum and maximum. So what are whiskers? Here to here. Here to here. Minimum and maximum. Minimum to maximum. Minimum to maximum. So these are called as whiskers. Outliers, points beyond a specified outliers threshold, plotted individually. So these were the quartile. So this is the largest value, this is the minimum value. And if somewhere the outlier will exist, that we need to represent as an individual. So that was the whole description of box plot. Graphical displays of statistical description. Box plot, graphic display of a 5-number summary. So that we have covered. Histogram is nothing but the x-axis are values and y-axis represents the frequencies. So we are having the continuous type of box plot representation, bar representation. So that is called as a histogram, that is having x values, x-axis are values and y-axis will be represented as a frequency. What are the frequency existing there? Quantile plot, in each value xi is paired with the fi, that is frequency, indicated that approximately 100 frequency percentage of data are less than equal to xi, that is a value. So quantile QQ plot is also exist. So what is this? QQ plot is nothing but graphs the quantiles of one univariate distribution that against the corresponding quantiles of the other. So that is the quantile of one univariate distribution against the corresponding quantile. Scatter plot is also there for to graphic display for the statistical description, in which each pair of value is a pair of coordinate and plotted as point in the plane. So if there is a x-axis, there is a y-axis, and here are some data points. So this is the scatter plot of the data set. So here the pair of coordinates are plotted in the plane. So that is called as a scatter plot. Data visualization. So why data visualization? Why we are using data visualization term? So to gain the insight, gain the graph and visual representation for an information that space by mapping data into graphical primitive that also provide quantitative overview of larger data sets. So data visualization we are using for the only larger data set in data mining, as we know. So here we can see the visually we can see the qualitative overview of the data sets very easily. So that is the use of data visualization. We will search for the patterns, trend, structure, irregularity, and relationship among the data. So these are the some of the trends occurring. These are the some factors we can check. Data visualization helps to find interesting regions and suitable parameters for further qualitative analysis. Further quantitative analysis. The data visualization provide a visual proof of the computer representation derived. So, from the larger data set, we have the better visual proof for to analyze any type of data. For to analyze and understand about the data, we can have the visual proof as a data visualization. So, categorization of visual methods. So, here some of the techniques we are having for that is pixel oriented visualization technique. First, second is geometric projection visualization technique. Third one is icon based visualization technique, hierarchical based visualization technique, and the visualizing complex data and relations. So these are the some methods we need to apply for the categorization of the visualization graph. So similarity and dissimilarity. What is similarity of the data? So for the numeric measure of how alike two data objects. If we are having two objects, that is how much similar are they, we have to measure that numeric measure. So that is called as a similarity. So the values is higher when objects are more alike. So when the two objects will be more alike, so the higher the value will be. That often falls in the range of 0 to 1. So basically, that will be 0 or 1, 0 or 1. If will be true, then it will be 1, that false, then 0. So this will be the similarity of the data objects. What is dissimilarity? That is only dependent on the distance of the data points, data objects. So the numerical measure of the how different two objects are. We need to measure the difference of the data. There we need to, in similarity we are calculating alike of the data. Here we will calculate the difference of the data. The lower where objects are more alike. So the value of the similarity will be lower when they will be similar. The minimum dissimilarity is often 0. So the minimum is 0 while we are measuring the dissimilarity. The upper limit that varies depend on the data objects. So the proximity refers to a similarity or dissimilarity. So the term proximity is uses for the dissimilar to measure the dissimilarity and similarity. So that was the dissimilarity and similarity of the data objects. So the data matrix and dissimilarity matrix. So we are having data matrix to represent that data to points for, in the form of a graph. So in data matrix we are having n data points with p dimension. So here we are having the data sets, the n data points, and p is the dimension. So total we are having x and p. This is having two modes. So we are also having dissimilarity matrix to measure. That is also the graphical representation of the data points, data objects. So here we are having n data points, but registers but registers only the distance. So in this dissimilarity matrix, we need to calculate the distance. So it is the triangular matrix. For example, if we are having some dissimilarity matrix, it is having 0, here nothing, here that is nothing but 0, 0, 0, 0, 0, 0. So here we are having the triangular matrix, that is nothing but the representation of the dissimilarity matrix. So here we are having D21, D31. So like that, this is having the distance. This is having the 2 distance, 1 distance. So we need to calculate the distance between both. So that will be here the point will be the dissimilarity. So the proximity measures for the nominal attributes that can take 2 or more states, that is, if we are having red, yellow, blue, green, so that will have the binary attribute. So that can have only 2 attributes. So in the first method, we will have the simple matching. So number of matches, if we are having M is the number of matches, P is the total number of match variables. So the dissimilarity of I and J we will calculate from P minus M upon P. P means total number of variables minus total number of matches upon total number of variables. So that will be the first method to calculate the dissimilarity of the 2 points. So in second method, what we need to use a large number of binary attributes, and then we will create a new binary attributes for each of the M nominal state. Proximity measure for binary attributes. If we will have the binary data points, so there are some formula to calculate that. So a contingency table for binary data, that is the contingency table, in which we are having object I 10 QSRT, here 10, and also we are having some Q plus R, S plus T and P, here Q plus S, R plus T, here sum of all. So the distance measure for symmetric binary variable, the formula is dissimilarity of Ij is equal to R plus S. R plus S is nothing but R plus S is nothing but the diagonal data objects summation. So here we will divide it by this QRST, whole of the data objects. So then we will get the dissimilarity of the I and J, that is for the symmetric binary variable. If we are having asymmetric binary variable, so we will need to calculate the dissimilarity of the object I and J. So we will have the calculation R plus S upon Q plus R plus S. So we'll get the dissimilarity of the Ij for asymmetric binary variables. There is also Jacob efficiency, that when we will have similarity measure for asymmetric binary variable. So we will calculate the similar Jacob Ij is equal to Q upon Q plus R plus S. So that will be the similarity coefficient for the Ij data objects. So Jacob coefficient is the same as the coherence. Coherence of the Ij we need to calculate as SUP of Ij upon SUP of I plus SUP of J minus SUP of Ij. So that is nothing but Q upon Q plus R plus in bracket Q plus S minus Q. So here we will need to calculate the coherence of Ij from this formula. So there was some formula for to measure the proximity for binary attributes. Dissimilarity between the binary variables. So we will take an example. So we are having a table that is having the columns name, gender, fever, cough, test 1, 2, 3, 4. And we are having the records of Jack, Mary and Jim. That is we are having in the form of M for F, M, Y, 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 N, 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 P, 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 N, 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 P, N, and N, N, N. So gender is a symmetric attribute here. The remaining attributes are asymmetric, binary. So let the values X and P be 1 and the value N will be 0. So we will calculate the dissimilarity of Jack and Mary. Jack and Mary. So here we will check if we are having dissimilarity of Jack and Mary. So we will have the value for N 0, value for P 1 upon y plus P plus Q. So that the dissimilarity will come as 0.33. The same we will apply for dissimilarity for Jack and Jim. So we will have the calculation 1 plus 1 upon 1 plus 1 plus 1. So the formula, from the formula we will have the result 0.07, 0.067. Similarly, we will if we will check the dissimilarity between Jim and Mary, so we will have the 1 plus 2 upon 1 plus 1 plus 2. So the result will be the 0.75. So what are the ordinal variables? The ordinal variables can be discrete or continuous. That is in that order is important. That is we have seen in earlier slides. The order is important, ranking is important, and that will be the only ordinal variable. So that can be treated like interval scaled. So this is the example. This is the steps we need to do for the ordinal value finding. So we need to replace XIF by their rank. Then we map the range of each variable into 0, 1 by replacing IS object into F1 variable. So what is the formula for that? ZIF is equal to RIF minus 1 upon MF minus 1. So we need to compute the dissimilarity using this method for the interval scaled variables. If you are having some interval in some variables, so then we need to apply this formula for that. Attributes of mixed type. If we are having some mixed type of variables, some mixed type of attributes in a database, so a database may contain all attributes type like nominal, symmetric binary, asymmetric binary, numeric, and ordinal. So one may use a weighted formula for their effect. So to calculate the dissimilarity of ij, we will calculate the dissimilarity from this formula. So here in the formula we are having summation p to f is equal to 1 delta of f to ij d of f to ij divided by summation p to f is equal to 1 delta f to ij. So we will have the dissimilarity of ij from that if we are having mixed type of attributes. So here f is a binary or nominal. So d of ij of f is equal to 0 if the x of if is equal to x of jf. Yeah, if d of ij is equal to 1. F is a numeric, then we use the normalized distance. And if the f will be the nominal, ordinal, then the computer ranks RIF and then treat JIF as an interval scaled as the first slide. At the earlier slide, we have calculated JIF is equal to RIF minus 1, MF minus 1 for the interval scaled ordinal values. So cosine similarity. So a document can be represented by thousands of attributes, each recording the frequency of a particular word such as keyword or phrase in the document. So this is the example. We are having the columns document, team coach, hockey, baseball, soccer, penalty, score, win, loss, and season. The records we are having document 1, 2, 3, 4. So we are having some data objects in that. So the other vector objects, that is gene features in microarrays. The applications are information retrieval, biologic taxonomy, gene featuring mapping. So these are the some application of that. So how to measure the cosine? If d1 and d2 are two vectors, that is term frequency vector, so we will calculate the cosine of the d1 d2 is equal to d1 dot d2 upon d1 and d2. So here the dot indicates vector dot product, and this the boundary d that represents the length of the vector d. This is the vector. So what is the example of cosine similarity? Here we will take the example. Find the similarity between the document 1 and 2. In earlier example, we have taken d1 is equal to 5030200200, and for d2 we are having 3020110 and 101. So we need to calculate d1 dot d2. So we need to calculate the dot product of the d1 and d2. So what will be the dot product? 5 into 3 plus 0 into 0, like that, so on. It will be the 25 will be the result. We need to check the d1 factor. So it will be the 42 of 0.5, that will be the 6.481. For d2 it will be the 4.12. So the cosine of the d1 d2 will be the 0.95 from the formula. So we have covered the various type of attribute like nominal, binary, ordinal, interval scaled, and ratio scaled. In this, we are also covered the many types of data sets like numerical, text, graphs, web images. So we gain sight of the data by basic statistical data description, that is nothing but the central tendency, dispersion, and the graphical displays of the data objects. We have also covered the data visualization, that we are using for the map data onto graphical primitives. We have also measured the data similarity of the data objects, and from the above steps are the beginning of the data processing beginning. And many methods have been developed, but still an active area of research is going on. So this was the summary of the introduction of data mining and the some data types. So thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.